All right, welcome sixth graders to lesson 4. Let's start by putting in the chapter title. Again, it's numerical expressions and factors. And the section 4 title then is prime factorization. Prime factorization. And this might be a new topic to you, but stick with me and I think you'll start to catch on today. For our learning target, it is I can use divisibility rules to find, and I'm going to abbreviate it, prime factorizations. So I'm just going to abbreviate it as PF. Prime factorizations of numbers. Okay. And we're going to be working with prime numbers this section, as you probably guessed. And I'm going to create some factor trees, and I'm going to show you some other ways that'll help for this section. Starting off with a little bit of vocabulary, it says because 2 is a factor of 10 and 2 times 5 is equal to 10, 5 is also a factor of 10. The pair 2, 5 is called a factor pair. Factor pair of 10. Okay, so basically 2 times 5 will give you 10. Whenever you hear the word factor, be thinking about the operation multiplication. Okay, so let's move on to our first example then. And it says the brass section of a marching band has 30 members. The band director arranges the brass section into rows. Each row has the same number of members. How many possible arrangements are there? Okay, so if I'm thinking of different types of rows and how many students I can have in each row, I guess I'll first start with there could be one big row, and it could have 30 kids in it. So one row of 30 would give me that total of the 30 members. Okay. Or if I think about it the other way, if I really wanted to, I could have 30 rows, and in each row just have one person. Okay, that's an option. Other possibilities, well, I could have 2 rows of 15, because 2 times 15 would give me 30. Or I could have 15 rows, and each row could have 2 people in it. Other possibilities, I'm going to keep going. I could have 3 rows of 10 or 10 rows of 3. And I think probably one of the last ones is I could have 5 rows of 6 or 6 rows of 5. Okay. And if I'm looking at this, how many different types of arrangements can I have? Well, I could have 1, 2, 3, 4, 5, 6, 7, 8. I could have 8 possible arrangements. Okay, and what we actually just did here is we found the factor pairs of 30, the numbers that multiply to get to 30. 1 times 30 or 30 times 1 is one of the examples. Okay, so 8 possible arrangements there. You'll be doing problems like this for the rest of the section as well too. So let's go on your own. I'll do the first one, see how I do it, then pause the video and try out number 2 and number 3. Okay, so what I like to start with for factor pairs is I really like to start off with 1 in that number and then work my way inward. So I start with 1, and then I ask myself 1 times what number is 18? Well, that would be 18. Okay, then I go to my next number that I'm thinking about to see if it's a factor pair. So next up would be 2. Is 2 a factor of this? Well, this number is even, so 2 has to be a factor. So 2 times it would be 9 would equal 18. So 2 and 9 are a factor pair. Going up to my next number, 3. Would 3 be a factor of 18? Let's see, 3 times 6 would be a factor pair. 4, no, 4 doesn't go into 18 evenly. 5, no, this doesn't end in a 5 or 0. 6, yes, and we already have it. Okay, so I don't need to list it again. So my factor pairs for 18 would be 1, 2, 3, 6, 9, and 18. Okay, why don't you go ahead and pause the video then and try 2 and 3 for yourself. Okay, factor pairs for 24 would be 1 and 24. 2 times 12. 3, is 3 a factor pair? Yeah, 3 times 8. 4, yep, 4 times 6. And that would be all of them. 5 is not. So quite a few factor pairs for 24. And then lastly, we'll end with 51. Again, start with 1 in the number. 1 times 51. Okay, 2, is 2 a factor? No, because this number is odd. 3. Okay, well, if you're wondering, remember you can always divide. So we could take 51, divide it by 3 to see if it comes out as a whole number. 3 goes into 5 one time, which would be 3. Subtract 2, bring down my 1. And 3 goes into 21 7 times with no remainder. So that's perfect. 3 would be a factor because 3 times 17. Are there any other factor pairs that you can think of? 4? No, not evenly. 5? No, it doesn't end in a 5 or 0. 6? No. This would be all the factor pairs of 51. And for checking these, a lot of them you can use some mental math, but if you want to use a calculator to double check on some bigger numbers, I'd be okay with that. I'm also going to give you another way to do this. So let's go on next to our key idea. All right. Our key idea says that here we're going to be talking about prime factorization. So here was the section title, prime factorization. Of a composite number is the number written as the product of its prime factors. So first we have to remember that a composite number is basically the opposite of a prime number. Prime numbers, let's write this down, prime numbers only have factors of 1 and itself. Okay. Composite numbers have a lot more factors. So for example, all of these numbers, 18, 24, and 51, are composite numbers because they have multiple factors. Okay, prime numbers only have factors of 1 and itself. Okay, so an example would be a prime number would be like 3. The only factors of 3 are 1 times 3, 1 in itself. Another prime number, 5. The only factors would be 1 and 5. Okay. So what we're going to do is break down these composite numbers as prime factors. It'll make a little bit more sense in just a second. And we can use factor trees to help us do that. So it says you can use factor pairs and a factor tree to help find the prime factorization of a number. The factor tree is complete when only prime factors appear in the product. The factor tree for 60 is shown. Okay, so let's do that here. Make a factor tree of 60. Okay, I'm seeing that I'm running out of time here, so I'm going to pause the video and then pick up in our next one. Okay, I'm back. So we're making this factor pair of 60, and a little hint for you is I like to start with 2, 3, or 5 when I break down this number using prime factorization. Okay, so I'll start with 2 here and ask myself 2 times what number is 60? And it would be 30. And then the second trick would be to circle your prime numbers. Okay, so since 2 is prime, I'm going to circle it. The only factors of 2 are 1 and itself. So it's a prime number. And I can't break it down anymore, so that's why I circle it. Okay, I can break down 30 because it is still a composite number. Okay, again, I'm going to use 2 here because this is an even number. And 2 times what gives me 30? Well, that'd be 15. Again, 2 is prime. I'm going to circle it. 15 is still composite. I can still break it down into 2 factors. I can't use 2 this time because 15 is an odd number. Can I use 3? Absolutely. 3 times 5 would give me 15. And hey, perfect. These are both prime numbers, so I'll circle them both. All right. So now for my final answer, a factor tree is complete when only prime factors appear in the product. Okay, here are my prime factors. I'll rewrite it as those circled prime numbers. So I have 2 times 2 times 3 times 5. I wrote down all my circled numbers times each other. And if I were to double check that, hopefully it would give me 60. 2 times 2 would be 4. 4 times 3 would be 12. And 12 times 5, yes, does equal 60. So this would be my final answer. I can shorten that up a bit and write 2 times 2 as 2 squared times 3 times 5 if I want. Okay, so this would be its most simple answer. All right, so probably your first time ever seeing that. We'll get some practice here. Let's try example 2 with the prime factorization of 48. Okay, so again, I'll change colors here. Start with your number, 48. And I'm thinking, can I break this down using 2, 3, or 5? Well, I see it's an even number, so let's try 2. 2 times what number would be 48? 24. And circle my prime number. I can break down 24 again. It's even, so I'll do 2 again. 2 times 12. Circle my 2. 12 is also even. I can break that down using 2. 2 times 6. And then I can break it down again as into 2 times 3. Now both of these are prime, and I'm finished. Need to rewrite my prime factorization, so I could write it as 2 times 2 times 2 times 2 times 3. Or if I want to save myself some space, I would do 2 to the 4th power, 1, 2, 3, 4 2's, times 3, and box my final answer. Okay, I just want to show you for tree 2, you can do this. You can break down 48 using different numbers if you want to, and you're still going to come up with the same answer. So say I wanted to break it down using 3. Okay, 3 times what number would give me 48? Well, you can check if you don't know. 48 divided by 3 goes in there once, which is 3. Subtract, get 1, bring down by 8, and 3 goes into 18 6 times for a total of 18. So 3 times 16 would give me 48. I'm going to circle 3 because it's a prime number. Okay, I can break down 16 into 2 times 8. Circle my 2. I can break down 8 into 2 times 4. Circle my 2. And I can break down 4 into 2 times 2. Circle both of those. And you'll notice I come up with the same answer as I did for tree 1. 2 times 2 times 2 times 2, or 2 to the 4th power, times 3. It's going to give me that total of 48. There is my prime factorization. Okay, so I will leave you with 5, 6, 7, and 8 to practice for the on your own. Hopefully you've got the hang of it by now. Pause the video, try them out, and I'll write the answers here after you try them out. So again, if you need some help and you don't get the same answers as I do, come see me, right? And the last thing I'll leave you with is kind of wondering, what is prime factorization used for? Mr. Gillis, why do I need to know this? One kind of cool thing that I found out about prime factorization is they're used when credit card companies are encrypting numbers. So they use prime factorization to do that. There's no algorithm to find it out. It's hard to hack, those types of things. So that's where it can be used. All right, try these on your own and see what you come up with. Okay, hopefully you arrived at these answers for on your own. So number 5, you should get 2 squared times 5. Let's see if that makes sense. 2 squared would be 4. 4 times 5, 20, yep. Okay, 6, you should get 2 to the third power times 11. Number 7, 2 times 3 squared times 5. And lastly, number 8, you should come up with 2 times 3 times 7 times 11. All right, hopefully you're doing okay on these. If not, come ask. All right, we'll see you next time.